Hello everybody and welcome to the next episode. Let's start. Today I will show you the contact enforcement methods in Abaqus standard. It is very important to know the default methods for using node-to-surface or surface-to-surface contacts and how to change the default methods if necessary. Some contact methods influence the result or can have an effect on convergence behavior. If you look in the documentation about the contact methods, you will find a table about the contact formulations. I want to discuss the red highlights area over the different contact formulations. The most used contact is finite sliding. Small sliding is needed to define an equal distance between the contact pairs. The direct method is used for contact pair type node-to-surface and is keeping contact always with pressure overclose. Please note that node-to-surface is default in contact pair. For finite sliding and contact pair type surface-to-surface, the default contact method is penalty. The penalty method approximates the contact stiffness. The third method is the augmented Lagrange method. It is default for finite sliding and contact pair type node-to-surface in 3D self-contact. Based on this table, another contact method combination can be selected for the different reasons. The direct method can be used for hard contact. It is the only method to use softening contact with pressure overclose relationships like exponential, linear or tabular. The penalty method can use for a linear or nonlinear method. The penalty stiffness for a linear method is 10 times higher than the underlying element stiffness, respectively the E module of the underlying elements. For clearance greater than 0, the contact pressure goes also to 0. The nonlinear penalty method can specify an initial stiffness and increase depending on the underlying element stiffness. The contact pressure can vary linear over the penetration. For more information, it is recommended to see the documentation. The augmented Lagrange method uses the penalty method to drive down the contact nodes. It needs more iterations but can avoid contact problems with overconstraints. The keyword surface behavior changes the contact method. It has parameter and options. With the parameter and the contact method, direct, penalty and augmented Lagrange can change. With the options, the pressure overclose relationship for the mechanical contacts can change. Here's a keyword example for penalty hard contact. The surface interaction definition with the name and keyword friction must be defined. When the surface behavior with the contact method and the pressure overclose type followed by the contact pair definition with the surfaces. In Abaqus CAE, there's a menu to edit the contact property to define the parameters for the contact method and the options for the type of pressure overclose. Default is the hard contact and the default for the contact enforcement method for the selected contact pair type. The edit contact property always allows an easy way to change and select another contact formulation. For the default contact method, the pressure overclose type is the hard contact as shown in the picture. For positive clearance, there is no pressure, but for small overclose, the contact pressure is immediately on the value of the possible mechanical pressure. Another way is to define a pressure overclose. The example is exponential type with parameter C and K. It can influence the way of penetration depending on pressure. This is sometimes a possibility to solve some convergence problems. For the penalty method, there's a linear option as default and a nonlinear option. With the nonlinear contact options, the contact pressure can vary linear over the penetration. The augmented Lagrange method can avoid problems with overconstraints if the penalty method shows some error about it. The follow simple example of two blocks in contact shows the influence of the contact methods. The lower block is fixed and the upper blocks as a force against the lower block. In all variations, the value of C press is constant. This is okay. but the results for COpen are different. For example, for type node to surface, an augmented Lagrange contact shows a COpen nearly 0. The example for surface to surface with default contact penalty shows a small interference COpen. This is the default result. The choose of penalty contact method manually has the same result. The direct contact with type surface to surface shows a COpen nearly 0, analog to augmented Lagrange contact with type node to surface, while the augmented Lagrange contact with type surface to surface shows a very small interference of COpen. In comparison to exponential pressure overclose, the COpen values is different to hard pressure overclose. If we plot the COpen values to the different contact methods, we get a wide range of COpen. The second example shows the different behavior between hard and exponential pressure overclose type. There's a small difference in the distribution of COpen in CPress. The conclusion is to know about the possibility differences and to decide which method you want to use depending on your problem. Thank you for watching.